Okay, our next problem is 6.4, and let's read the question first. The truss used to support a balcony is subjected to the loading shown. Approximate each joint as a pin and determine the force in each member. State whether the members are in tension or compression. Set P1 is equal to 20 kilonewtons and P2 is equal to 0. Now we have a system, as you see, balcony. It's bolted at the joints, and but it is told us to approximately each joint as a pin, since all the joints are intersecting at one point. We have a force P1, even though it is drawn in the figure, the P2 is excluded. It is pin jointed at C and E. So as a result, both vertical and horizontal motions of C and E is restricted. Since this balcony can freely rotate around C and E if we isolate it, there is no reaction moment at C and E. Okay, so first step is to draw the free body diagram of the system. I have P1, external load. We have the support reactions in horizontal and vertical directions. Logically, we choose the horizontal axis as X and vertical axis as Y. As a result, we have FCX and FCY as reaction forces at support C, and at support E we have FEX and FEY as support reactions. Now, first step is to find the support reactions, of course. In order to do that, we write the moment. So we have, remember that we have three equilibrium equations in plane. One is the moment and the force in X and Y directions, respectively. So you can take the moment with respect to any point. Indeed, I prefer to take the moment with respect to point C first. As you see, I have four unknowns. This basically means that I need four equations in order to find the support reactions. But let's see, and let's proceed in the question. First, I take the moment with respect to point C. This will eliminate the contribution of the forces to the moment equation at point C. In fact, Fey will not generate any moment because it directly it's aligned with the point C. It is directed towards the point C, and as a result, it will not generate any moment. Therefore, I can calculate the moment Fex if I take the moment with respect to point C. So from P1 to the point C, it is 8 meters. And from E to the C, it was 4 meters. As a result, the moment equation is P1 multiplied by 8 plus Fex multiplied by 4. And this has to be equal to 0. From here, I can easily calculate the Fex. Fex is equal to minus 2 P1. Since P1 is 20, the result is minus 40 kilonewtons. Now next, I take the moment with respect to point E. Now if I take the moment with respect to point E, this will eliminate the contribution of the forces at point E. Again, Fcy passes from point E. As a result, it will not generate any moment, and I will be I'm left with Fcx and P1. If I write the moment with respect to point E and saying that it is equal to 0, P1 multiplied by 8 minus Fcx multiplied by 4 is equal to 0. Now this gives me Fcx is equal to 2P1, and from there I can find the Fcx as 40 kilonewtons. Now Let's write this force equilibrium. If I write the force equilibrium in x direction, I will see that Fex and Fcx will eliminate each other. One is minus 40 and the other one is 40. I don't have any other forces in x direction. As a result, this validates my calculation. Sum of the forces with respect to x is equal to 0. Now, next thing is sum of the forces in my direction has to be equal to 0. If I write the sum of the forces in my direction, I have Fcy, Fey, and P1. As a result, I can easily say that Fey plus Fcy has to be equal to P1 because P1 is in the opposite direction. But certainly, I only know the value of P1, and I need another equation to solve the to find the value of Fey or Fcy. So let me say that this is equation 1 at the moment and leave it so. Now remember that next step in the solving the truss systems with method of joints is numbering the members. So I say that from A to B is the member 1, member from B to C is 2, member from B to D is 3, member from C to D is 4, and member from D to E is 6, and member from A to D is 5. So these are my members. I have 6 members. Now, in fact, if I look at the problem and look at this joint E, at this point, I have only one member connected to the support. Okay, and it is horizontally aligned. And remember that I don't know the components of the forces in my direction. So I don't know Fey. So let's focus on this joint because this has the least number of elements at the moment. There is only one element connected to this joint. And let me continue from this point. So let me draw the free body diagram of the joint E. Now I have F6 here, I have Fex and Fey. First thing is writing the equilibrium condition in x direction for the joint E. Certainly sum of the forces in x direction has to be equal to 0. If I look at the forces in x direction, I have only F6 and Fex, and that has to be equal to 0. So F6 plus Fex has to be equal to 0. This means that F6 is equal to Fex, and remember that that is equal to minus 40 kilonewtons. If we write the sum of the forces in my direction, this gives us the value of Fey. So Fey is equal to 0. Now remember that I find the value for Fey. This means that at support E there is no force in my direction. Now I can calculate the support reaction at point C. From equation 1, I can easily say that Fcy is equal to P1, and that's equal to 20 kilonewtons. Now I have found all the forces, all the support reactions. Now, next point is to go to the joint B, because it is the second joint with least number of, it's the third one, but there is something related with it. as you see, I have two members connected to it, and there's another one perpendicular to this one. Now let's see what happens at joint B. Now at joint B, I have F1 and F2 and F3. And F3 is perpendicular to F2 and F1. If I write the sum of the forces in x direction, I can easily see that F2 is equal to F1. That's okay. If I write the sum of the forces in y direction, it tells me that F3 is equal to 0. So F3 or member 3 does not carry any load. As a result, it's a zero force carrying member. There is no force acting on it. It basically means that even if we remove it, the structure will work, continue to do its job. Okay. Now we don't know the values of F1 and F2. So next step is to analyze the joint A. So at joint A, I have external load P1. It's in negative y direction. I have F1 and F5. Sum of the forces in x direction is equal to 0. Now from here, I can easily say that F1 plus F5 multiplied by cosine 45, because member 5 makes an angle of 45 degrees, is equal to 0. And if we write the sum of equilibrium equation for y direction, minus P1 minus F5 multiplied by sine 45 is equal to 0. Now from this equation, I can easily find F5. F5 is equal to minus P1 divided by sine 45. If I submit the values, P1 is 20, sine 45 is square root of 2 divided by 2, I will obtain 28.284 kilonewtons. So let's write the unit. Never forget to write the units. Okay, now I find the value for F5. From the previous equation, from this equation, now I can calculate the value for F1. F1 is equal to minus F5 multiplied by cosine 45. And this gives me, by the way, this is minus 28.284. And this gives me F1 is then 20 kilonewtons. So now I know the value of F1, and in fact, I know the value of F2 because I know that F2 is equal to F1. Now I solve the, I write the equilibrium conditions for joint B and A. Next is joint C. So at joint C, I have FCY, FCX, F4 and F2. Okay, I already know the value for F2. In fact, the only unknown is F4 here. If I write the equilibrium equation in x direction, so sum of the forces in x direction is equal to 0. From here, FCX minus F2 minus F4 multiplied by sine 45 is equal to 0. Now this gives me the expression for F4 because I already know the value of F2. F2 is, remember, that 20. So F4 is equal to FCX minus F2 divided by sine 45. If I submit the values into their places, 40 minus 20 divided by sine 45, this gives me the value of 28.284 kilonewtons for F4. So the positive sign tells me that it is tension. If I write the equilibrium condition in y direction, it gives me, it validates my calculations, because F4 multiplied by cosine 45 is equal to minus FC, is equal to FCY, and this validates my calculation. Now, the last step is the joint D. Now, certainly I already calculated all the values. So let me write the sum of the forces in x direction. It is equal to F6 plus F4 cosine 45 minus F5 cosine 45. And I will see that that is equal to 0. This validates that my calculations are correct. And sum of the forces in y direction has to be equal to 0. And from there, it is F4 multiplied by sine 45 plus F3 plus F5 sine 45 is equal to 0. This validates my solution also. So overall, if I look at the problem again, I can easily say that F6 is compressive because it is negative sign. So let me continue. F5 is compressive. It has negative sign. F1 is tension, in tension. F2 is in tension. F4 is in tension. And as a result, I can easily find the members that are in tension and compression depending on the sign, if I choose the forces always in tension initially.